So hi everyone, welcome. Thanks for joining. My name is Gary Taylor, and today I'm going to run through the latest updates as well as an intro on SCION, which is a new routing protocol. It's going to be a very short session, and this is part of our ongoing series of Megaport Live tech drop-ins. So Megaport is a network as a service provider. Essentially, we provide the ability for customers to consume networking services in exactly the same way you would consume cloud services. So real-time, scale up, scale down, delete, migrate, etc. So what makes the Megaport NAS platform different? Well, firstly, the reach. Megaport NAS is part of a virtualized global ecosystem built on pre-existing hardware. This gives you the ability to deploy capacity to all of the well-known cloud service providers, giving you access to thousands of IT-based services, as well as connectivity to other data centers and IX services around the globe. It is predictable performance. It's like having your own private fiber lines, making it highly secure. Your data travels on our private global network with no internet within the core. All of these components can then be linked together with virtualized network cross-connects. We call them VXCs, and they are typically layer 2 MPLS pseudo-wires. And as stated, this can all be done in near real time, just a few minutes, and the service is up. You pay only for the capacity you wish to deploy. It is pre-built and virtualized, and you can scale that capacity up or down on demand. You no longer have to worry about traffic spikes or wasted capacity. This ensures good end user network performance. This makes NAS services very cost effective. This can all be designed, deployed, and be fully operational in minutes and be available for only the term you need. This reduces your upfront infrastructure cost to zero. Also, your time cost is zero. As your Megaport assets are virtual, there is no capital investment or hardware provision. It's also worth mentioning egress fees for all cloud providers via the Megaport partner on-ramps are significantly lower. So there's a potential data cost saving option as well when you're using private cloud access. So you can design, deploy, manage, and monitor all on a single secure platform. It's point and click. You bring your cloud service keys, and this makes establishing private networking simple. And everything is fully API integrated, as well as a very mature Terraform provider available as well. Just to give you a scope of some of our the coverage of Megaport, nearly 3,000 customers, over 30,000 services, and we have access or coverage in over 1,000 data centers as well. And those 400 plus service providers includes obviously cloud, but a lot of our partners who've actually exposed their services via the marketplace. This is a quick snapshot of our global reach. You can access Megaport in over 1,000 data centers. Please note down here, where is it? There we go. When we say installed, that's where we have locations that has Megaport hardware, physical hardware in, and then enabled is where you can actually connect to the Megaport location via a metro connection or a campus cross connect. We spent more than a decade building a truly massive global network across 1,000 data centers, over 400 service providers, and 26 countries. We've deployed kit in sites around the globe, physically interconnected those sites, and then established NNIs with hundreds of service providers, including the hyperscalers like AWS, Azure, Oracle, IBM. Over the top of that network, we've deployed a customer software layer that gives you complete control of the network using our web portal or via code using Terraform or API. Obviously, this map is representative of the network. It doesn't include every POP or physical route available. Just a quick overview of the options that are available from a connectivity point of view. So on the left here, we have what we call hybrid cloud. Here you connect your infrastructure via a cross connect into a Megaport, and that is a physical device, essentially an Ethernet demarcation device, where capacity is from 1 gig, 10, 100, and now 400 gig is being rolled out as well. We then have virtual POP. This is an on-demand network function. Here you can deploy virtualized SD-WAN gateways, virtual routers, virtual firewalls in minutes, in real time, in over 90 locations globally. And then on the right, we have what we call cross-cloud, where we spin up a virtual router. It handles traffic between the two, obviously 2 or more clouds, but we support up to 25 VLANs per virtual router. And the name of our virtual router is Megaport Cloud Router or MCR. So quick updates on the latest from Megaport. We've deployed IPsec on MCR. My colleague Fausa did a fantastic overview of IPsec on our MCR product, which is our layer 3 virtualized routing instance. It was in Italian, so I thought I'd just do a quick overview of some use cases that are available. But obviously, any questions or if any proof of concepts you want to run, please contact us and we can set that up for you. So obviously, first use case here, we've got an MCR. We have deployed a private connection into Azure. It's via an express route circuit. We then have another private circuit into AWS, and that's via their direct connect hosted connection. We then deploy internet, and we then enable IPsec. So this essentially connects as an VPN gateway where you could have branches, end users, head offices connecting securely into that MCR, and they can then access multi-cloud in a completely encrypted manner. The MCR doesn't just do IPsec. We've exposed a fair amount of features on that service, so we can support from a BGP point of view, ASPath prepending, med values, we support BFD, and we also support prefix filtering. So you can actually filter subnets or IP addresses as well. And we've recently enabled access controllers. So you can actually filter based on source, destination, and port. So acting as a basic firewall. It's not a stateful firewall, but it's a packet filter as well. And that's all inclusive in the cost for the service. Obviously, the IPsec tunnels are an additional cost, and it's based on 10 sessions per block of IPsec services. Then moving on to another use case. So in this case here, we have the same thing. We've deployed a MCR in a diverse zone, which we've labeled red and blue. We've done the same thing here. We've connected via an express route connection into Azure. And then we've done the same thing on the other side, which is in a blue zone. So that is full diversity, and that is consistent diversity end to end. This can be in the same data center, or it can be in another DC in the same metro. And then we run IPsec. So this is a fully diverse active-active solution, IPsec, so cloud to cloud delivered on an encrypted solution end to end as well. It's worth noting though, with Azure, they have an express route service called Metro, and that's available in certain countries only. It's being rolled out. But for example, in Amsterdam, the standard express route deployment would be into one data center, AMS5 or AM5 Equinix. What Azure are now doing is offering the ability to connect into another data center at the same cost. So in the case of Amsterdam, you can have primary going into Rosenberg, which is near Schiphol Airport. You can then have the backup connecting into Equinix, which is about 10 or 15 kilometers away. So that is giving you at the same cost as giving you DC diversity, giving you geo diversity as well, separate hardware, separate connectivity, and you can actually deliver that into AWS as well, where you have color coding. So you can deliver a fully end-to-end solution, all driven by Terraform. And you can actually completely write a script that can actually deploy this for you in a few minutes. So then coming on to our MVE vendors, we have a couple of new vendors as well. The first one we have is Anapaya, and I'll come on to what Anapaya offer in the next slide. And then we've also just launched Juniper SSR. So moving on to Anapaya, this is a very high-level view of what they do. What makes them quite unique is that they support a new routing protocol called SCION, which stands for Scalability, Control, and Isolation on Next-Generation Networks. And the whole idea of SCION is to overcome the limitations of the current internet. So I'm going to provide a very high-level overview of what SCION can do. And obviously, for more details, please contact us. We can set up a proof of concept, set up a test environment for you quite easily as well. So introduction on SCION, the current internet. You could say obviously the internet when it was built, it uses BGP for dynamic routing in the 80s, and there was implicit trust between the networks. You have a very high number of interconnected networks, over 75,000, and definitely in the 80s, security was definitely not a focus of what BGP can do. The expectation was that all ASs, autonomous systems, will only announce routes that it can reach. so valid routes. And obviously, there's a view that the networks would actually own the addresses that they announce. And logically, that the addresses that they own, they would then correctly send packets to the other side. Now, obviously, that's not the case. And their assumption was there'll be nothing malicious in how BGP is operated. And we know 35, 40 years later, that is not the case, and is a very much an untrusted global network. What SCION does, it essentially solves that internet problem. It separates the control and data planes. It prevents DDoS attacks. It prevents, certain attacks because it's based on trust. So within SCION, everything is cryptographically signed. So you cannot join the network unless you have the authority to do so based on PKI. It's got much better fault detection. It is multipath by design. So it was built with multipath in mind, and the alternative paths are already pre-configured. And then the path failover is by design. You could be 10 hundreds of milliseconds, but typically under 50 milliseconds. And the endpoint, the end device, actually has the ability to control the path it takes. Obviously, BGP is handled centrally, and an end device literally has to send that data through to the next hop. And where it goes from there, that user or that office or that company has no control. What SCION does, it gives you that level of control at an endpoint, so you can actually choose which region your traffic can enter, or rather, you can say, do not traverse these countries, only traverse the following countries. It's decentralized, so decentralized trust model. It spreads the load across the network. So essentially, it's got much better performance. It's got flexible routing. Users choose a path. And because of that, it's got much lower latency as well. So on that, I'll say goodbye. If you need any more details of what SCION can do and how we can actually work together with Anapaya as a vendor, please let us know and contact us and we can run through a POC for you. With that, I say thank you and see you next time.